Hey, welcome back to Common Core Algebra II. Today's lesson 10.4 is adding and subtracting of rational expressions. So 2 guidelines for addition and subtraction of fractions. Back when you were in 4th grade and you first learned how to add and subtract fractions, you knew how to find a common denominator. All right, and the denominators can only be changed by multiplying the overall fraction by 1. So let's go back and see if we can remember how we did this back in the 4th grade. So I'm going to do this kind of a long way, but I think it's going to be a way that you can make sense of it. So if you remember, this is how I learned it. I used to do it like this over 4x, and then we would add 4x plus 2 over 6x. And then you'd find the common denominator between 4x and 6x, and you'd say, well, I know that 12x is a good number, or sometimes people learned to multiply the 2 to 24x, and that's all right too, because you're just going to simplify it at the end. So remember, what you're really doing here is you're multiplying by 1. So in order to get from 6x, so let's start here, from 4x to 24x, I have to multiply the top and the bottom by 6 over 6. So what am I left with up here? So 4x times 6 is 24x. And now when you represent the numerator here, it's going to be 6 times 2x minus 5. And here, 6x times 4 gives me 24x. But now I have to make sure I multiply the numerator by 4 and come out with this. So now when I add this, I'm really just adding my right side now. My common denominator is 24x, and my numerator is 6 times 2x minus 5 plus 4 times 4x plus 2. And now we're just going to simplify by distributing. So we get 12x minus 30 plus 16x plus 8 over 24x. Now we're going to combine like terms. So 12x and a positive 16x is a positive 28x minus, and we have negative 30 and a plus 8, which is minus 22. I'll slide this down a little bit, over 24x. And if I reduce this all by 2, I get 14x minus 11 over 12x, which is my final answer. Remember, we're not solving anything here, we're just simplifying. No equal to signs, so nothing to solve. So that's kind of going back to the way that we did things in 4th grade. But now what I want to do is I want to take a look at how to do it in 10th, 11th, or 12th grade, depending on where you are. Okay, but in Algebra 2. So let's take a look at B and set it up a different way. Here's B. So we have 4x minus 1 over 5x plus x plus 5 over 10. So what I'm going to do here is I'm going to find my common denominator. And the common denominator here is going to be 10x. Because the largest number that the smallest number, the least common denominator, is 10, and then we have 1x there. So what we're going to do is, when you think about this 10x, what am I missing now? So when I do this, if I put a 10x up here, what am I missing? The x's go out, the 5, and we're missing a 2. So my numerator becomes 2 times 4x minus 1. And what am I missing here when I think about a 10x? The 10's cancel, but I'm left with that x. So x times x plus 5. And now, that's the hardest part, because the rest of it is just using the distributive property and simplifying. So let's use the distributive property here. So we get 8x minus 2 plus x squared plus 5x divided by 10x. Now we're just going to combine like terms. I have an x squared. I'm going to put it in descending order, which means the highest exponent goes first. So now I'm going to work with my x's. So plus 13x minus 2 over 10x. We're just going to leave it that way. We don't have anything else to factor. It's not a factorable quadratic, so we're kind of done with that one. Let's try it one more time with letter C. Hopefully it's going to become a little bit easier. Determining what that common denominator is, the least common denominator, that's the hardest part. So if I look at 4 and 2, the least common denominator is 4, because that's the smallest number that 4 and 2 both go into. And then I have to use x squared because I have an x and an x squared. And x can go into x squared, and x squared can go into x squared. So now, again, what I'm going to do is consider each one of these and consider that 4x squared that we're multiplying by. So what do we have left over? This cancels with this, but I have an x left over. So my left-hand fraction just is going to have a 3x plus the x squares cancel here. This cancels to a 2, so simply I'm going to have 2. All right? I'm going to remind you, these are protected. You cannot cancel out the x's. All right, now we're going to move on to a little bit more difficult ones, but you might find them to be easier because you're using factoring and it's not quite as bulky as some of these are. So let's take a look at exercise 2. So the fun thing about these are you get to do all kinds of factoring and then determine what your common denominator is from your factors. All right, so exercise 2 says combine each of the following fractions by factoring the denominators first, then find a common denominator and add. So notice this says nothing about solving. There's no equal sign here. So the first thing I'm going to do is I'm going to rewrite each of my fractions in factored form. So 4 over, and on the left-hand side, I can see that I don't have a squared term here, so I'm going to look for a GCF. So the greatest common factor here is going to be 5, and what am I left with? It's y minus 3, right? Because basically what we did is we took out a 5 out of each one of these. All right, now plus 5 over, and hopefully you've got red flags going on here because that 9, we have y minus 3 and y plus 3 because that's the difference of two perfect squares. I'm hoping after all of the other rational expressions we've done, this is becoming a little bit easier for you. So now, remember, we're not canceling here. This is not like what we did before. This is about finding a common denominator. So the nice thing about this is when we find a common denominator, it just has to include everything here. So I'm going to write down what I have here in the first fraction. And now if I look in the back fraction, what am I missing? I have a y minus 3 right here. So I'm missing a y plus 3. So that's my common denominator. And again, we're going to multiply both of these by that common denominator. So it's y minus 3, y plus 3, 5, y minus 3, y plus 3. And I put this because I think it's easier to see what I'm canceling. Because in here, I can cancel my 5s, I can cancel the y minus 3s, and I'm left with the y plus 3. So in my numerator, I'm left with y plus 3. All right, now in the second fraction, I'm going to cancel out both of these, x y minus 3 and y plus 3. I'm sorry, y minus 3, y plus 3. And I'm left with the 5, this 5 here. So I'm going to get 5 times 5. All right, so now I'm going to simplify my numerator, and I'm going to redistribute this so I get 4y plus 12 plus 25 all over 5 y minus 3, y plus 3. And these take some room to do, so please make sure, once again, that you are taking the time and the room to do this. If you need extra space, go to Post-its, go to lined paper, go to wherever it is you need to go. So we do our final combining of like terms here, and we get 4y plus 37 all over 5 parentheses y minus 3, y plus 3. And you can leave it that way. So there's your final answer. Could you multiply out your two binomials in the denominator? Yes, that would be fine. But if this is a constructive response, then you don't need to. You're done. So in letter B, why don't you pause the video and see if you can factor these, all right? Factor your denominators and see if you can decide what your common denominator is going to be. So we get x minus 3 over, we're going to factor this into two binomials, and this should be coming pretty easy for you because you're doing it a lot these days. So we're looking for, because we have a leading coefficient of 1, we're looking for two numbers that are multiplied to 20 and add to give me negative 9. And the answer is going to be negative 5 and negative 4. I know the signs are the same. Plus the 2 in the numerator here. This is going to be x and x. I need negative 6. So what two numbers, same number, that are going to multiply to 8 but add to give me 6? Well, 2 times 4, so that means I'm going to have negative 4 and negative 2, right? Because negative 4 times negative 2 is positive 8, and negative 4 plus a negative 2 is a negative 6. So hopefully you figured out the common denominator. I write down everything on the left, so x minus 5 and x minus 4. And if you did this properly, you should really just have one more thing you have to add. They should have something in common. All right? So now again, you're going to multiply each of these by that common denominator. You're going to multiply, and I'm running out of room here, so let's do it here. X minus 5, x minus 4, x minus 2, and I'll do it here as well. X minus 5, x minus 4, x minus 2. So what are we canceling out? The x minus 5s, the x minus 4s, and I'm left with here is x minus 2. So I'm going to have that x minus 3 that I have right here, and I'm going to multiply that by x minus 2. Now I'm going to keep the 2 that I have in my numerator right here, and when I cancel out these two with the x minus 4 and x minus 2, I'm left with x minus 5. So take a minute, look at that, make sense of it, and then why don't you go ahead and simplify your numerator here. So using distributive property, I get x squared minus 3x minus 2x plus 6, that's this one, plus 2x minus 10, all over our common denominator, which is x minus 5, x minus 4, x minus 2. So let's do some combining of like terms here. So I have this, and this, and look, these two cancel. So I get x squared minus 3x, and then I have a plus 10, and a plus 6 and a minus 10, which is a minus 4, all over my common denominator, x minus 5, x minus 4, and x minus 2. And I always ask myself, I have a quadratic left in my numerator now, and I want to ask myself, is that factorable? And if it is, and I can cancel out one of these, that's kind of a little bit of a bonus. So this, we can factor the numerator because we have x and x, and we're looking for two numbers that multiply to 4 but subtract to give me 3. So this works, it's 4 and 1. And I know the negative has to be with the 4, so I get a negative 3. And if we did this right, which I think we did, x minus 4, x minus 2. Now we can do one final simplification by eliminating our x minus 4s, and our final answer will be x plus 1 over x minus 5 times x minus 2. Now, I'm just going to remind you, if this is a constructive response, you're good. If it's multiple choice, they could multiply the bottom, the denominator out to get x squared minus 7x plus 10. So this one or this one would be an acceptable answer. I know these are kind of long, and this video is going to run a little bit longer than some of the other ones, but we have 4 exercises to try to do in exercise 3, where we're going to start talking about subtraction. All right, so if you need to pause or rewind to write anything down, do that now before we move on to exercise 3. Okay, subtraction of rational expressions is especially challenging because of errors that naturally arise when students forget to distribute the subtraction or when you multiply by -1. So let's take a look at A together, and then I want you to try B, C, and D on your own. All right? So perform each of the following subtraction problems. Express your answers in simplest form. So we're going to follow the same procedure we just did. We're going to find our common factor. Now, the beautiful thing about A is we have a common denominator already. So we have the same common denominator, so we're simply going to do x squared minus 4 is our common denominator. So that means we're going to multiply, well, not multiplying, I'm sorry, we're subtracting. Make sure that you protect these, all right? So that way you know subtract x plus 3. Because if you put them in parentheses right away, it makes that negative sign between the two of them a little bit more apparent. So we have 3x plus 7. We can just remove the parentheses there because there's nothing in front. And this negative sign, there's a couple of different ways that you can approach it. Some people like to approach it as a -1 that they're distributing. Some people like to think about it as a rule that you just change all the signs inside the parentheses that follow it. So basically what that means is a -1 times a positive x is a -1x. And a -1 times a positive 3 is a -3, all over x squared minus 4. And now we're going to simplify that. So we have 3x minus 1x. 3x minus 1x is 2x. And we have positive 7 minus 3, which is plus 4, all over. Now that x squared minus 4, we're going to rewrite all of this now because I can factor both numerator and denominator. So I can factor out a 2 out of my denominator and get x plus 2. And that denominator, hopefully you're seeing, is the difference of perfect squares. I've seen that since the beginning. Hopefully you have too. And then the last thing we're going to do is cancel these x plus 2's out, and we're left with 2 over x minus 2. Okay, it might be helpful to keep that in parentheses so you don't cancel out the 2's. All right, so now on B, you're going to find your common denominator first and then subtract. So maybe this one we should do together too, and I'll let you do C and D on your own. So first things first, let's find our common denominator. Let's factor, I'm sorry. So we have x minus 3 on top, and we have 2 on top in the numerator. So now, how am I going to factor the denominator on the left side? Well, once again, we have the difference of 2 perfect squares, 2x minus 1, 2x plus 1. And on the right-hand side, we're just going to pull out a common factor, the greatest common factor in this case, which is 5. And we're left with 2x plus 1. Well, that's nice. Like I said, you should have at least one that is shared between the two denominators. So, next step, what is my common denominator? I have 2x plus 1. I'm sorry, minus 1. Let's just keep it in order. 2x plus 1. And the only thing I'm missing is the 5 out of the one on the right. So let's put the 5 out front. Get rid of some of There's my common denominator. So we're going to multiply this one and this one by our common denominator. So what am I missing? Well, I have this one and this one. I have this one and this one. I'm missing the 5. So I'm missing the 5 out of the x minus 3 minus, what am I missing in the second one? Well, I have a 5 and I have the 2x minus 1. So I have the 5 and I have the 2x minus 1, so I'm missing this one. So 2 times 2x plus 1. And now we're simply going to simplify it. Multiply out the numerator by distributing. So we get 5x minus 15. Now this is where things get a little tricky. Remember, it's negative 2 times 2x, which is negative 4x, and it's negative 2 times a positive 1, which is a negative 2, all over our common denominator. Now let's simplify this. Just erase some of our little check marks here so we can move downward. So our common denominator is still 2x minus 1, 2x plus 1 times 5 over. And here I'm just going to do some combining. So I get an x, and I have negative 15 and negative 2, which is minus 17. Okay, I'm sorry I'm going to do this to you, but I realize I just made a mistake because we're missing here a 2x minus 1, all right, which makes this a plus, which makes this a 13. Negative 15 plus 2 is negative 13. All right, I knew there was something wrong there, but that's it. That's the only place I seem to have made a mistake because my final answer is going to be the x minus 13 over 5 times 2x minus 1, 2x plus 1. All right, so hopefully some of you picked that up because over here I said I had this one and I had this one, and I was missing the 2x minus 1, and that's what I should have put right here instead of the plus 1. Yep. Even the smartest people make mistakes, so pay attention. The only difference between us is most of the time I catch mine. All right, so I want you to try C and D on your own. I want you to pause this video right now and try these on your own, and then we'll come back and we'll go through the solutions.